Have you wondered why we yawn? Even in most unexpected times? Prepare to have your mind blown as scientists have finally unraveled the mystery behind yawning, and the revelation is nothing short of astonishing. Brace yourself for the shocking truth about this enigmatic phenomenon that has puzzled humanity for centuries. With groundbreaking research and cutting-edge technology, experts have unearthed an unexpected link between yawning and the secret workings of our brains. Get ready to challenge everything you thought you knew about this seemingly mundane act. Yawning is characterized by an uncontrollable broad opening of the mouth and widest possible expansion of the jaw, as well as a long, deep inhale through the mouth and nose, followed by a gradual expiration, all of which are connected with a sense of comfort. The average human yawn lasts about 5 seconds. Additionally, humans frequently stretch their limbs after yawning. Yawning and arousal. According to the available data, tiredness is the most typical yawn-inducing stimuli. When the primary stimulant in a person's environment can no longer hold their interest, boredom sets in. Boredom stimulates our brain's sleep-generating system, and this causes drowsiness. The drowsiness stimulates reflex yawning, which is the mind exerting effort to stay in touch with the outside world. The resulting mechanical stimulation of the carotid body is thought to be the cause of the arousal that follows yawning. This structure's strategic placement causes it to be stimulated by the compressions and movements brought on by yawning. Being heavily vascularized, the carotid bodies may experience compressions that influence their shunt system, causing the release of chemicals like adenosine and catecholamines, which then mediate the arousal response. Yawning and brain cooling. Another physiological function of yawning is that it regulates the temperature of the brain. It has been postulated that yawning might cool down the brain when its temperature increases. And evidence for this proposition comes from a research in which the prelimbic cortical brain temperature recordings were continuously monitored during the 3 minutes prior to and following a yawn. It was seen that cortical temperatures were significantly raised until the onset of yawn, followed by a significant fall and return to baseline in the next 3 minutes after yawning. The physiological consequences of yawning are analogous to those which are needed to effectively cool the brain, such as increase in the peripheral and cerebral blood flow. The contraction and relaxation of facial muscles during a yawn increases the facial blood flow, which subsequently aids in dissipation of heat through emissary veins. The gaping of mouth and deep inhalation of cool air during a yawn also alters the temperature of blood going from the lungs to the brain via convection. Tearing from the eyes, which some people experience at the peak of yawn, may likewise play a role in dissipation of heat from skull. Patients with clinical disorders such as multiple sclerosis, epilepsy, migraine, stress, anxiety, head trauma, and stroke experience excessive yawning, which is followed by temporary cessation of their symptoms. This is because these conditions lead to an increase in the body core temperature, thereby resulting in abnormal thermoregulation, which the body then tries to correct transiently by way of yawning. Yawning and social empathy. The empathetic foundation of contagious yawning is supported by neuroimaging investigations. Significantly higher functional magnetic resonance imaging activations in response to contagious yawning have been observed in posterior cingulated area, bilateral superior temporal sulcus, bilateral ventromedial prefrontal cortex, and posterior cingulated area. Although all of these brain areas are divergent, They are parts of a distributed neural network related to empathy and social behavior. Contagious yawning has recently been linked to the brain's mirror neuron system, a group of neurons in the right posterior inferior frontal gyrus. Mirror neurons are thought to be crucial for perception and understanding of motor actions, which is a requirement for true imitation, or the exact copying of a goal-directed behavior. Adult humans and some other animals use yawning as a component of their action repertoire for communicating and empathizing, which would explain why yawning plays such an important social functions. Yawning and ear pressure. During sudden changes in height in elevators and airplanes, people frequently have ear discomfort and hearing issues that can be relieved by yawning. The eustachian tubes are opened as a result of the tensor tympani and stapedius muscles contracting and relaxing, respectively. This observation has given rise to the theory that yawning may actually be an ear defense reflex that is activated by sudden changes in altitude or other circumstances that cause air to become trapped in the middle ear. This reflex aids in balancing the air pressure in the middle ear with the air pressure outside. Yawning and brain hypoxia. A long-standing belief about yawning is that it is brought on by inadequate blood or brain oxygenation, which occurs when oxygen, O2, levels drop and carbon dioxide, CO2, concentrations increase. Yawning is supposed to improve brain oxygenation and remove bad air from the lungs. Brain state transition. Yawning has been associated with transitions between different states of consciousness, such as transitioning from wakefulness to sleep or vice versa. It is important to note that these theories are not mutually exclusive, and multiple factors could contribute to the occurrence of yawning.